Hello, and thank you very much for coming today. Welcome to GDG Milton Keynes. If you are looking to join us or you'd like to find out further information about us, you can reach us on any one of these channels here on these social platforms. We're on Twitter, we're on LinkedIn, we're also on YouTube. You're probably watching it right now there. And we're also on Meetup. So first of all, for you guys here, thank you very much for coming. We really appreciate it. GDG Milton Keynes, or should I say GDGs in general, are all about inclusivity. It's about making people feel welcome and being able to collectively share, learn, and figure out new ideas and how they can benefit you in whatever shape that may be. It may be at your work, it may be on hobbies, it may be on projects that you're dealing with right now. Or it just may be that you've got a particular interest in some kind of technology and you just want to find out more information. So great reasons for coming here are, apart from the amazing pizza which we're going to be having delivered in a few minutes, probably about an hour-ish, is that you get to meet new people and you get to network. So you can find out further information from your peers as well as all of the people that you'll meet today. Incidentally, we're also, of course, broadcasting this and live streaming it from YouTube. So for those of you who are watching it, wherever you are, whatever time zone you're in, thank you very much for joining us. Of course, there are some benefits to being here in person because you could get to talk to the presenters directly straight away. So you could potentially speak to Doug Sillars. He's right here, but he's just over there waiting in the wings. And you can find out a lot more information that way. So I do highly recommend that if you're interested in a particular technology, do take the effort and the time, and if you can, to actually come here in person, because that's what it's all about, is making those connections. Okay, and don't forget, if you are watching this on YouTube, please like, subscribe, and obviously share the video as well. Okay, so that's it. Thank you again. All of the information that you're seeing here is actually on the description of the video. So if you want to just scroll down a little bit, you can join us on any one of those social channels. And I'm going to let Doug do his thing now, and we'll hand over to him. Thank you.
Thanks, Rob, for the introduction. I'm Doug. We're going to talk today. I'm doing two talks, one about video streaming and one about augmented reality. So sort of related, but both really interesting talkings. How many of you have ever built anything with video for the web? Awesome. Streaming or not streaming or streaming? Awesome, cool. This is sort of an introduction, so hopefully it's not too introductory for those of you who have done video streaming stuff, but we're gonna start and just talk about video streaming and how we can avoid stalling, like this airplane is actually stalling here. So I'm Doug. I'm a freelance developer relations. I do a lot of stuff around web performance. So we met at the GDG London Summit, something like that. We were supposed to be roommates and we ended up not being roommates, but that was fine. So I help people make the web faster. I help people make native apps faster. If you do any Android development, I wrote a book on how to speed up Android apps, and that's the PDF, so you can download that. And then if you ever need to get a hold of me on the internet, I'm really the only Doug Sillars out there. So if you Google me, you will find me. I'm on Twitter, email, and I have a website. So why video? Why do you want to put video on your web page? Web developers, those who don't do video? Web developer, awesome. Native apps? Awesome, this is a wild group of people, lots of different interests. But why video? So this is from Wistia, and they found that the average time spent on a web page, the blue lines are ones with video and the orange ones are websites without video. So people whose websites that had video on the page, people spent more time there. Now, this is Wistia marketing Wistia video, and so they've got a really good reason to make you think that putting Wistia videos on their webpage is going to make you stick to the webpage more. And it also sort of makes sense. If you put a 5-minute video on your webpage, guess what? If somebody watches a 5-minute video on the webpage, they're going to stay on the webpage for more than 5 minutes. But really, all the research does show that if you put video on a webpage, people are more engaged and they hang around a little more often. So Wistia found that people found 2.6 times longer on a web page that had video versus sites that did not. But video streaming, why would you stream a video versus just, use the video tag and throw up an MP4 on the web page? There are a couple of reasons for that, and we can go into that if you have questions later. I cut out all the stuff on the video tag from this talk so that we could go home tonight, because I have a lot of information on video content. The video tag has no media queries, so you can't change, like with the picture tag, you can have different size pictures for different size screens. For the video tag, you can't do that. So if you have a 1080p video, you're serving a 1080p video to people on their laptop, to people on their phone, right? Unless you do some JavaScript to serve different videos. Once you've chosen that video, you're stuck with that video. So if you decide that your customer's on a really, really fast connection and you start playing a video and they go onto a slower connection, like they get onto a train, they're stuck with that high quality video. The opposite can be true as well. If you think they're on a really slow connection and you give them a really crappy video and then they get to a faster connection, they're still stuck with the cruddy version of the video. And there's things like alternate video audio tracks and things that we can do with streaming that are really exciting as well. So when you talk video streaming, I don't know what type of videos. Did you do video on demand type stuff?
No, it's a church. So
okay. You were live streaming.
Live streaming.
Nice. Super cool.
People in Peterborough.
Nice.
They watch
as you're doing it. That's awesome. So live streaming is really cool and a really awesome technology. I'm going to talk more about video on demand, because video on demand is sort of the basics, and then live streaming, it adds a lot more technical complications to it. There's also unicast. So unicast is basically for everybody requesting a video, it goes back to the server and through the cloud. So like you have 2 streams for 2 users, 6 streams for 6 users going back to your main servers. There's a thing called multicast, which they're working on. And so where multicast gets really interesting is for things like World Cup soccer, World Cup football, sorry. I'm an American and I'm working on my language. And so what's great about multicast is if you can serve some of it from the cloud, you don't have the load on your main server isn't quite as big. I'm only gonna talk about unicast right now, like just, video on demand, Netflix, Amazon streaming, things like that. I'm not going to talk about live streaming. Live streaming is like your church does live streaming, or like football is live streaming. Like there's a lot of really cool things. There are a lot of real interesting technical challenges when it comes to live streaming. I don't know how much latency do you know how much latency you were seeing with the live streaming? No. You just go and it works. That's awesome. A lot of people have talked about, live streaming is really cool, and there's a lot of latency, there's a lot of delay with the live streams, and there's a lot of research to make live streaming a lot faster. I kind of joke that when you do live streaming, when you watch a football match at the pub, it's usually about 5 or 10 seconds behind real time. So if you're at the pub and the stadium is next door, you hear like, yeah, right? But if you're above the pub, watching it on a live stream, you hear the stadium, you hear the pub, 30 seconds later, yeah, right? There's about 45 seconds to a minute of latency with live streaming. And there's a lot of work to make it down to like 5 to 10 seconds. But it's an issue. Like I was live streaming a American football match just because I had some time and I was bored and I was watching it. And then I was also following like the real-time thing on ESPN, and the ESPN was 2 plays ahead of what I was watching on this, the real-timeness of it is very interesting. So we're going to talk about video on demand. It's still super complicated, but it's not as complicated as live streaming. There's 2 primary technologies used today for video on demand. There's a HTTP live streaming. That's an Apple format, but that's what everybody uses today. Everyone uses HLS. MPEG-Dash is coming. There are people using MPEG-Dash. It's the standard. So there is going to be a lot more people moving to that. But right now, pretty much everyone's using HLS. Like that's just the format that most people are using. So that's what I'm going to use in my examples today. on how it works. So the way it works is you've got a video, and in this case, it's video on demand, so it's already been created. So it may be an MP4 file that you've got somewhere. And what HLS does is it breaks it into segments. Each one of these segments is just a few seconds long. And it depends on how you encode it. Sometimes they're 10 seconds long, sometimes they're 2 seconds long, like lots of different implementations to do this. And each one of these is a .ts file. And there's a manifest file that describes all of them. So you've got this giant text file that says, here's the first 2 seconds, here's this, 0 to 2, 2 to 4, 4 to 6, et cetera, et cetera, et cetera. And it's a text file that tells the player what to do with all of those files. And it looks sort of like this. So the beginning of it says, each segment is 10 seconds long, blah, blah, blah. Here's the information. This first segment is 5 seconds long. It gives you the byte range, and there's the URL to find it, right? And so you've got 3 different segments described here. So this text file is describing each segment that the player should download and play. Where video streaming gets really cool is you can have multiple streams, and each one of them is described by a manifest. What's nice about these is they can all be different quality, they can be different dimensions, and they're all cross-linked. So if you start with a 1080p video, but then you find out that the network can't handle it, you could switch down to a 720p video or even a smaller one. Or you could go the other way around. You could go, as the network gets faster, you could go back up to a higher speed video. So having these multiple streams allows, this is where the adaptive bitrate comes in. If the network changes, if you're on a train and you go into an area with low coverage, it may drop to a low quality. Then when you get back into high coverage, it can spring back up to the high quality stream, and the video never stops playing. Yeah?
If I understood you correctly, you said those are linked, which means that if I'm in the video at position 2 minutes 30 seconds,
yes,
and I get bumped to a higher or lower stream, I would retain that position. It's just with a different
quality. Exactly. The player can link those back up, so it will know you're at 2 minutes and 30 seconds. Yeah. Oh, but your network is getting really poor. Let's kick you down to the lower quality at 2 minutes, and you're probably 4 seconds ahead. So it may go to the lower quality at 2 minutes 40 seconds or something like that. And so you'll see that sometimes, like when I'm watching how it's downloading things, it'll stay at the high quality, but it's downloading ahead of time, right? So it drops to a lower quality, and then it drops to lower quality later. Each one of these manifests is actually, then there's a parent manifest that describes all of the smaller ones. So this is the one that describes all of the different bit rates, all of the different dimensions that are available. And because it knows which ones are available, it can then point to the children manifests for the actual files to download. So you've got all these streams, and so this is what the parent manifest looks like. And you have 3 different streams right here. And each one of these describes the bandwidth, so that's in bytes per second. It describes what codecs the video is encoded in, it describes the resolution, and then it has a link to that child manifest file. I actually like to look at it this way, because what this tells us is that the first stream is 1.3 megabits per second, the second one is 800 kilobits per second, and the third one is 545 kilobits per second. The codecs are all the same, and then if you look at this way, you can see the different resolutions, 720p, 540p, 360p. So now you can actually read this and understand based on, if it's serving stream 1, you know that it's 720p video. If it's stream 3, you know that it's 360p video. So it can do all of these transformations live, and you can understand what's going on. So there's this really cool tool called the HTTP archive. And the HTTP archive scans 5 million web pages every month and looks for all of the files that are downloaded are stored in a database. And so I actually went through and found 26,000 manifest files. The manifest file has the extension M3U8 for HLS streaming. When I did the test, only 16,000 actually worked. I curled them all and downloaded them all to my machine. Because we can, right? We have the technology. 2,700 of them were the master manifest files, listing different available tracks. So you can also, when you're doing streaming, is you could have a stream that just describes one track, and you could have only one available track available. So some websites do that. Yeah, go ahead.
That seems like an awfully low number because surely there's more than 2,700 videos.
So the way the HTTP archive works is it only goes to one page per website. So if CNN is in the directory, it goes to www.cnn.com. It's going to bbc.co.uk. It's not going to all of the article pages. It's literally 5 million pages in the database. So so obviously this is not a super representative sample because, the folks at Netflix really know how to do streaming, and the folks at Amazon really know how to do streaming, or the folks at YouTube really know how to do streaming. We don't get those. We're only getting the ones that were available in the data set. But what we can see is we can look to see how many different streams are listed in those files. And you can see by far the majority, the most common one is 6. So they have 6 different screen sizes and dimensions available in the manifest file. There are a few up here at 12, which seems like a lot. One reason I think 12 is a lot is you have to have 12 different encodings of that video stored somewhere, right? There's a cost. Having lots of different dimensions and bit rates are nice, but there's a cost. If you have a 10-minute video and you encode it 10 different times, you have 10 videos that you have to store. If you encode it into 10 different bit rates, you have 10 videos to store for each one video you have on the web page. So there is a cost, but it's interesting that 6 is the most common. There's a fair smattering of 2 to 8, which is interesting. So how do you create one of these streams? There are a couple different ways to do it. This is an example with Cloudinary. So Cloudinary is a cloud-based media tool. So you upload the video, and then you just change the end of they give you a URL. So you upload an MP4. You change the end of the URL to M3U8, and then they have a bunch of different profiles with different sizes and dimensions, and you just put a parameter right there, and it generates all of the streams for you. And so this URL just works, and it does it for you, and they do all the hosting of all the files. So it's kind of convenient and super cool. If you want to do it with FFmpeg, you don't use, these are the Cloudinary docs, but this is a bash script that will do it with FFmpeg. So FFmpeg is a command line tool. This is a script, and the script, I have it here open. Let's see if let's come out of presenting mode for a second. What it does is it's just a script, and it creates a whole bunch of streams. It basically creates all the different formats for you, and it creates the manifest files and puts it all into one folder for you, which then you have to upload into a server somewhere for it to work.
Does it do the encoding as well, or recoding?
It does. It recodes it into all the segments for you, and you get just a folder with all these files on it.
I meant transcoding, and that's free, and even the storage space is.
So for FFmpeg, so FFmpeg, you're doing this locally on your local machine, or you're doing it in an EC2 instance, or wherever you have the video. You have an MP4 file, you run this bash script, it will create all the files for you. It is an open source software, so this is free to do. All right. Then you have to host it. So you have to worry about the hosting costs for the video here. So Cloudinary will do all of the hosting. I'm gonna put this in presentation mode, and then I'll go back one. It's thinking. All right, so Cloudinary will host all of the files for you, and they'll do all the transmission for you, and it's free to a limit. And then once you get past a certain amount of transport a month, you have to start paying. But they will do all of the hosting, and they have a CDN, so they use Akamai or Fastly, so it's put out around the world, so it's fast delivery. And it's free to a point. They have a very generous free tiers, but with video, it's very easy to go over the free tier because I've done it. Video files are big. The great thing about doing streaming is if you don't do the 4K and maybe the full HDs, you're using a lot less data for each video. I see a lot of web pages that are just using MP4s on their web page, and they're doing full, 1080p video to mobile phones that are probably viewing it in portrait mode, so they don't need that type of resolution. You could go a lot smaller. So that's one great thing about HLS streaming, is that it will serve the right size video to the right size screen. So if most of your users are on mobile, they may only be getting, some of these lower quality streams because that's the size of the screen. Yeah.
When you put up, when you start HLS, is the device that's showing the video, is it automatically picking the appropriate video?
That is an awesome question, and we'll get to it in my next 3 slides. So it's a great lead in. So you create an HLS stream, whether it's with Cloudinary or with, I didn't change the title here, or with FFmpeg and you host it somewhere. If you hit that URL with Chrome, it downloads. If you hit it with Firefox, it downloads. HLS is an Apple product, so you hit it with Safari, it plays. And with Edge, it downloads. So you need a player. So if you're doing this in the browser, you need to add a player onto your web page. It's basically JavaScript. 3 popular open source players are HLS.js, Video.js, and Shaka Player. They're all JavaScript files. You can find them online. They're free. They're open source. There are also players you can pay money to use, and they work really, really well. When I was doing my comparisons, I was using the free ones because it's easier to do comparisons on free things. When you
configurable as well.
Yes,
right?
When you have no budget, it's easier to test the free ones. Yeah, they're all very configurable, and you can do a lot of cool things with them. And I'll talk about Video.js, but they basically give you the ways. There's a lot of documentation on how to add them. There's a script. This is using the Cloudinary player because this is just a script that I use as an example. But it's really easy to. They're really easy to set up. The documentation is really well written out, and you can actually take their boilerplate code and just put in the link to your video, and generally they work really well. What is interesting though is some of these players are not responsive, and so I'll describe what that means. Is I took a video that had a bunch of different dimensions, and I loaded it into these 3 players, and I gave the player a width of 720 pixels or a width of 360 pixels. And what you can see is HLS.js and Shaka Player download like 13 to 15 megabytes of video, whereas Video.js only downloaded 8. When I resize it to even smaller, they still download 15 or 13 megabytes of video, whereas Video.js only does 2.7. Video.js looks at the size of your screen and then picks the bit, the size, the player or the manifest file is saying, hey, this one is 960 by 540, and says, well, I know that I've only got this size, so I'll use that size video. HLS.js and Shaka.js look at the network speed only. So they say, I can download a whole lot of video. And they do that no matter whether you're on a mobile phone that can't handle 1080p video. These 2 players were downloading 1080p video for a device that didn't need that many pixels. So it was downloading lots and lots of data, and then the phone had to retranscode it to make it smaller so it fit on the screen. So you really want to use a responsive video player because then it's going to download the right number of pixels so it fits on the screen without overloading your servers, which can cost you money, right? If every single person downloading is downloading 15 megabytes, or if all your mobile users are downloading 8, you're going to save, it's going to be twice as cheap for you to use that, especially if you're using something like Amazon that charges you by the gigabyte of data that comes out of your server, or Cloudinary. They all charge you for how much data you use. You can make HLS.js and Shaka responsive. They're not responsive by default. So there's a parameter that you can add. They're highly configurable players, so you can add lots of parameters, and you can say cap the level to the player size, which means don't serve a bigger file than the size of the screen. And Shaka Player has a similar, but they're by default off, which to me seems wrong because it just ends up wasting a lot of data for people who don't need those video files. When I turn on the responsive option, you can see that both HLS.js and Shaka go way down, and they all have a different algorithm. right? They're all serving slightly different amounts of video, but they're doing a much better job than they were earlier. So, right, this is one of those things that you have to test and look to see what the different players are using. If you choose to use the HLS.js player, it's worth doing some testing while you're, scoping out the different players. Of the ones that I found, of all the websites that were using HLS.js, so I went through all of the JavaScript that were on the pages, because it's all in this HTTP archive, and only 3% of them were actually using the responsive parameter. Because it's optional, most people are just taking the boilerplate code from the sample docs and pasting it on the web page, and they don't know about this, and they're not realizing how much data they're wasting. So it's important to think about this. This is interesting stuff. I think it's interesting stuff. So we talked about the stream count a little bit. So what if it isn't responsive by default? And this was your question. What happens if so if it's responsive by default, it'll say, Doug's phone is, 700 wide, so we'll serve the 960 by 540 video, right? We won't serve the 1280 by 720 because he can't even see that many pixels unless maybe he goes into landscape mode. But the player will know Doug just switched into landscape mode, and you can switch to that higher resolution video. So it can know if I'm in portrait mode, it'll serve that one, and then maybe switch to the, the 720p when I go into landscape mode. But what if it isn't responsive by default? What the player does is it just grabs the first one on the list to start playing the video. This can generally be okay, but then you have to start thinking about the order you place the order the files are in the manifest. This is an example, and the video is broken on this web page, but it was working last month. So this is live from a web page. This is from a web page in Argentina that teaches you a driving course, like the DMV. You have to take a driving course before you can get your driver's license in Argentina. And the first stream on the list in the manifest file is 1080p video. I mean, that's big, but probably they're using a desktop, but if on mobile, that's probably not going to play very well. What's tricky is look at the bandwidth. And it's a number here, so it's really hard to see how big it is. So I added some commas. That's 37 megabit per second video. That doesn't play anywhere. That's a lot of data you have to download. You need a really fast connection for that to work. And if you look at the second one, it's 21, and then 6, and then 2. Like the first 3 or 4 streams here are ginormous. They're huge. They're really, really big. And they're not going to play on a mobile phone for sure. I've tried it when this webpage was still live. I tried it on a really, really fast internet connection. And the player still said, boy, that's taking too long. And the player switches it to a lower bitrate video. So you should never, in my opinion, start with a really, really high bit rate because it's going to take a long time for the video startup. And one of the main metrics people use for video is, did the video start quickly? And if you're trying to start at 37 megabits per second, it's going to take a while for that video to start up. So it was like the first 2 seconds of video was like 4 megabytes. So it was taking a long time. It eventually fell back to, I think it even went lower than this one. It went down to like the 234p video, like the lowest quality. So when the player can't play the highest one, it usually switches all the way down to the lowest quality. So basically all it does is add this really slow start to the video, which is a bad metric. You always want your video to start up quickly because if it takes a long time, people will scroll past it, or they'll just never watch it, or they'll abandon. And it wastes data. So they actually fell back to the 270p, which is 350 kilobits per second. That's going to play on almost any connection because it's 350 kilobits per second. Like it may not play on a 2G connection. Yeah, question.
The number is a bit surprising. So if the 540p is still 6 megabits per second.
Yes.
So
they've got it encoded at a very, very high quality.
Exactly. For the high resolutions, one they just forgot to turn on the Compression?
They forgot to turn on the compression. So there are a lot of things we can do to make videos smaller, right? You can compress them, just like images, right? If you take an image with your phone, it's 12 meg, you know, it can be 12 megabytes or 6 megabytes. You don't put that on the web. You do some compression and resizing before you put it on the web. You can do the same thing with videos. This is like almost like a raw video that then they turned into segments. Like this is ginormous and way too big, and probably doesn't really belong on a governmental website. It doesn't belong on any website, but definitely one that's like supposed to be for the people to examine. It's way too big. What a lot of websites do is they begin the list with the lowest bit rate. And why do you start with the lowest bit rate? Because it's going to download the fastest and start playing the soonest. So that's why when you watch a video, you'll see this with Netflix sometimes, where even the beginning of a Netflix movie is really pixelated and grainy. And the reason they do that is the video is going to start up really fast. And usually with a Netflix movie, the first 4 or 5 seconds of it anyway is it's fading into like 20th Century Fox or something, right? It's not really important to the beginning of the story. So if it looks bad for the first 5 seconds, you're okay. So then what it does is it starts with the low bit rate, then the player knows the speed of the network after a couple seconds, and it switches to a higher bit rate, which is why when you're watching it on Netflix, or you're watching like a news article or something, like a news segment, it gets sharp after about 4 seconds. Because it starts off with a low quality, and it's like, oh, they're on a fast connection. We can get them a higher quality video, and it sharpens. So the player does that adjustment. But the initial video is of low quality. And so this is an example where I start with the lowest quality video. When I start with the lowest quality video, you can see the video starts playing faster than any of the others, but it's a low quality video. When I start with the highest quality video, it takes like 6 seconds longer for it to start playing. And what's interesting is this quality, it started trying to download the high quality video. It didn't work, so it started with the lowest quality video. The quality right here is the same as this one. It just took 6 seconds longer, which means you're going to lose customers, right? They're not going to hang around for another 6 seconds to watch the video. I call this the Goldilocks approach. And this is what Amazon does. It starts all of its videos with a middle bit rate. They know people watching an Amazon TV show, they're going to hang out for a few seconds longer. They're already going to sit down for an hour to watch the, whatever it is, The Man in the High Castle or whatever. So they start with a middle bitrate quality. It takes a couple seconds longer, but it's sharp from time 0. So if you ever watch like an Amazon original, a lot of times it doesn't start with a black screen. It starts with a full color, full palette screen because it's sharp from the very beginning of the video playback. And so that's one of the ways they try to differentiate themselves from the other video streaming players, is they start with a really high quality video from the beginning. And so I call it the Goldilocks approach because they don't take the biggest one and they don't take the smallest one. They pick the one in the middle that's just right. When I look at those 2,700 videos that are in the HTTP archive, 3/4 of them start with the lowest bit rate because that makes sense, right? That's the fastest startup. And then the last 25% kind of break it up how they do it. But only 10% start with that highest quality video. Other things to look at is when you look at the streams, this is the number of kilobits per second that are being used. And the line right here, this is 1.5 megabits per second. And why 1.5 megabits per second is important doesn't matter here. But if you're building video streams for an American audience, in America, cellular providers limit video streaming to 1.5 megabits per second. They sell it by saying you get unlimited streaming, but they give you crappy quality at unlimited streaming. So they call it binge on or stream saver. And what that happens is if they notice that it's a video stream, they don't let any of those bit rates play. They just throttle the connection to 1.5 megabits per second. When we're not on video, we can talk about like the net neutrality implications of that. I am a former AT&T employee and I am happy to talk about it off of camera. They don't call it throttling, they call it saving. it's a lot better marketing that way. If they said, can we throttle you for free? Nobody would sign up for it. We can look at the different dimensions that are being served. 720p is pretty popular, 1080p is pretty popular, but we do have a lot of these lower dimensions so that it will play on any device, any slower networks. Other really awesome things we can do with video streaming is you can have alternate audio tracks. So this is from Web Page Test, which is showing me all the downloads, and the green are video files and the gray are the audio tracks. So you can serve different audio tracks to different users. If you have it in German or Spanish, you can serve those tracks and they can just change the audio track with the streaming. And it's just all built into the way streaming works. And so the way that works is you can see right here, we have an audio track in Russian and an audio track in English. And then it just lists all those different things. Yeah.
Are those audio tracks separate from video? And can you
Yes, they're separate. So you've got a video track that's silent, and then you've got an audio track in English, and then an audio track in Russian, or whatever language you want.
But you can also have audio right in the video.
You can have audio right in the video track as well.
But you can opt for having.
And I think you could have English in the video track and then have Russian as a secondary track that it would just turn off the audio from the video track. And then you may end up using more data that way because then you're downloading both English and Russian at the same time. But this is really neat, and I think I have the web page open, so let's do a live example of it. But this is a Russian web page. It's going to translate it. But this is the video. And I don't know if it's going to play on the...
Yeah, I don't think it will.
I don't think it will either. But what you can see here is it will go... And you can't hear it. Anyway, what you can see here is we've got Russian and English. And if I have it on Russian, you can hear the people on the panel talking. If I switch it to English, you hear like the guy in the back who had the headphones on who was live translating it. It's kind of neat, right? It really adds a different dynamic to what your web page can do or what your website can do. If you have multiple languages available, it immediately expands the audience of the people who can experience your web page. Obviously, it's a little bit more work because you have to have somebody else read it and transcribe it in real time. But it's kind of a neat idea. There are tools out there that will give you subtitles, and I did talk about subtitles, but you can add subtitles to this as well. And there are actually tools that will take your English, that will transcribe the English into subtitles so that you can have subtitles on your web page. And then the Azure function that does that will actually translate it into multiple languages for you. So it'll actually take like the audio track of me speaking here, and it will translate it into, they have like 35 different languages. So they can translate it into Thai and put Thai subtitles at the bottom. Obviously, if you're putting that on your web page, you should have somebody who understands Thai to make sure that it's not like saying horrid things. I have noticed that the subtitle tools screw up things like names of companies, right? So if all of a sudden Google turns into goggles or whatever, right?
Okay.
It's just not, right? You need to make sure that it's translating even the computer taking my English words and turning it into English text, you should check it to make sure that it makes sense. Same thing if it's going to a different language, you should probably have someone who speaks Spanish look at the Spanish subtitles. But you can do it automatically. And then you could do so this is subtitles. So if you ever go to a TED Talk online, they always have now it's playing it in, it's on the, let me find that tab and close that. Now it's working. But that was the Russian segment. But you can generate the subtitles, and then you have WebVTT, so that's video text, and so those are the subtitles. If you ever go to a TED Talk and you click the subtitles, they have like 27 different languages with subtitles available. And so this is a copy of it, so you could have English, Danish, Russian, German, Greek, and Spanish, and those are the subtitles. Azure has a function that will actually translate them into all those different languages for you, and it'll do like 27 different languages, and it's relatively cheap. If you pair it up with Cloudinary, it's free for like your first 10 translations. So it's really super cool. And it counts one translation. So if you do like 27 languages on one video, it counts as one translation. Like it's totally wild. So I took this video I found online and I translated it into Chinese, and like there were characters across the bottom. I have no idea what they said. I hope it was accurate. But you can do subtitles in your streaming as well. And so TED Talks use HLS streaming. So if you go, you can actually look at the manifest file and you'll see all the different languages. And then of course you can click these and they're text files. So you can download them and open up your favorite text editor. And you can like see how TED does their streaming. And it's kind of fun to like reverse engineer how these companies do these things. So each stream, like I sort of mentioned with Cloudinary or with the FFmpeg, you know, you'll get a stream and it'll break down how those are all created. And so with that, I didn't actually get to those two tools, but you know, there's Cloudinary. The link to the FFmpeg streaming, how to do that bash script to do it, is in the talk. I didn't get it onto the final slide, so sorry about that. You'll have to dig through my talk to get it, but I will post the slides onto the meetup page.
Yep, and we can
afterwards.
Put that back onto the video.
Onto the video as well. That's awesome. These are some tools that I built to measure video quality. I don't know if, are we out of time?
No.
Okay.
A couple of more minutes.
Couple more minutes. So what I find really interesting is there are a lot of tools out there to measure how fast a web page works, but nothing will tell you how fast the video starts onto the web page. So I built a tool that will do that. This is actually a quiz of web pages that screw things up, which might be fun to do later. But let's just get to the, sorry, I've got a lot of data. FFprobe is built into FFmpeg, and it will give you all sorts of information about the video. So what's cool about that is, like on a Mac, you can get info and it'll tell you the dimensions of the screen. There's nothing that'll tell you that about video. FFprobe will do that for you. And I built a web version of it right here. So you just put in the URL of your video as, you know, as an streamclarity.com probe URL equals, you put your video there, it'll tell you the quality of your video. So like web page test will tell you that a video downloaded, but it doesn't tell you how quickly it starts. So I basically built a tool that if you go to this web page, you enter the URL of your video, it will tell you how long it took for your video to start playing. And if it's over 5 seconds, you're probably losing customers because it's taking time for your video to start playing. This is based on the network speed of your browser. So you can use Chrome DevTools to slow down your network connection to see what it looks like on a 3G connection, a 4G connection. Maybe you can change the different speeds of your browser, and you can see how long it takes for your video to start. You can let the video play to the end. Let me just click through all this. Oh, it's got an API, so you can run it with like different devices around the world with web page tests. So like I've got that all documented on GitHub. It will also measure how often the video stalls. So it'll show you how much video is in the video buffer. So the buffer is how much is on the screen, is downloaded. And if you get down to 0, that means the video stalls. It's played everything that's local to the computer or to the device. Nothing has downloaded. You get to 0, the video can't play because there's nothing left for it to play. When a video stalls, you lose customers. People get abandoned the video when it stalls. So this will also tell you if the video stalls. It's all documented. It's actually really cool. I think it's really neat because it's actually all just JavaScript running this, but it will tell you how well your video is playing. And I'll just do a live demo because, like, why not? So here it is. And what's neat is the default video I have on here is actually, if you look, it's a stream. So it's actually going to show you how this stream plays. Actually, let me go back. Let me go into DevTools. And I'm going to make it a 5 megabit per second connection. I'll make this bigger. It doesn't need to be mobile. So I've slowed down my network speed to 5 megabits per second because I think the Wi-Fi here is probably pretty fast.
Yeah, pretty good.
And so what happens here is the video is playing. You can see how long it took for the video to start. And you can see that I've got 30 seconds of video in the buffer, right? So this video is probably not going to stall. So what I should actually do is slow it down even more. I'll make my network speed slow 3G. You can actually see we've almost filled up the buffer. But it's actually off the screen on my graph. But what this line means is it said, oh, the network speed got slower, so I'm switching to a lower quality video bit rate because the network speed just got a lot worse. But there's still a whole lot of video in the buffer. This video isn't going to stall, right? There's 40 seconds in the buffer. What I will do is, because Chrome isn't very good about this, I'll open it in incognito tab and we'll try again. I've noticed that videos sometimes cache, even though you tell the dev tools not to cache things, sometimes the video still caches. So we'll make the network, we'll make it a slow 3G connection, and we'll just start from scratch. And we'll have it go. So it's auto playing the video. It's a slow connection, so it's going to take longer. It may not be super realistic. But it started, you can see, at the lowest bit rate here. And it's really slow. It took 11 seconds for that video to start. And you're going to see, like, the amount of video in the buffer, uh-oh, it just stalled. Right, we're on a really low, right? We can see it's staying in the yellow and the orange, right? We're really in danger of this video stalling a lot. But with the adaptive bitrate, it's still playing on a slow 3G connection. Yeah. This is a very slow connection with a lot of latency, and it's not really stalling. Like, it's actually playing pretty well. If I give it more speed, see, I gave it more speed, and you can see it jumped to a different bit rate, a higher bit rate. It goes red if it goes to a lower bit rate, green if it goes to a higher bit rate. It jumped to a higher bit rate. It's now not going to stall at all, and it's going to play.
So one question about the bit rate. Does it look like we see the bit rate anywhere? Because it still says...
It didn't change it. No, it's a to-do on my list of things to write on the software. This is the initial bit rate. Okay. And if I had something in the middle, you'd see it go from green to red, green to red. Sometimes it bounces back and forth. It can't really decide where to go. Like, it's really interesting to see how the players behave. It's sort of like in between speeds where it's not sure what the best bit rate is. It'll bounce back and forth between different streams. But anyway, that's the live demo of that. So there's a way, we have ways to identify how the video is playing back, which I think is really important. And then I also built a tool that will look at the quality of the video, because if you add compression, right, that Argentinian video, those 37 megabits per second, really high quality, it's gonna look great. If you compress it, it might start looking bad, so there's tools that will actually analyze that and tell you how that looks. We can talk about that on the break, because I think I've run out of time. But thank you so much, and we'll talk about augmented reality in a few minutes after the break.